Good day, participants of the event of the NAM International Workshop on Technology Transfer and Commercialization. Welcome to Breakout Room 2. Let me introduce myself. I'm Amir Manurung, and I'm going to become the moderator of today's event. In this room, there will be 6 speakers that will receive each 10 minutes of speaking time. I was also informed by the organizing committee, should any participant is interested in something, please write your question in the chat room, and then we are going to address it in the section after the speakers give the presentation. Now, let's make a move. Let's make it quick. So I'm inviting Dr. Nyoman, Professor Nyoman, Ni Nyoman Tri Puspaningsih from Universitas Airlangga Surabaya. Your staff, ma'am, I believe have provided your CV, which is quite lengthy. So let me take the honor to summarize it, which is as follows.
Recording in progress.
Okay. Professor Dr. Ni Nyoman Tri Puspaningsih, MSI. She received the BSc degree in chemistry from Universitas Airlangga Surabaya in 1986. The MSc degree she gained from the Department of Chemistry, Biochemistry from ITB, Institut Teknologi Bandung in 1994. And the doctorate degree from Department of Biology from Institut Pertanian Bogor 2004. She did a fellow course in Japan and some postdoctoral doctoral fellows in the Netherlands. She became a full tenured professor in biochemistry in 2010. Since 2021, up until now, she's the Vice Rector for Research, Innovation, and Community Development at the Universitas Airlangga. Related to the pandemic COVID-19, she is appointed as coordinator of COVID-19 research product in Universitas Airlangga. In fact, she has already intentionally published and awarded 2 national patents in this matter. Additionally, she is also active in domestic and international scientific networks. Right, so Dr. Ni Nyoman, I'm inviting you to display your presentation, and if you're ready, we can have 10 minutes of your presentation time, please.
Yeah, thank you, Dr. Manurung, for the time. So, good afternoon for the guests who joined this workshop. I would like to share. This is already clear, Dr. Manurung?
Yes, very, very clear, ma'am.
Yeah. Thank you very much. So, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for all the guest speaker also who joined this afternoon session for the international workshop on transfer technology and commercialization. So today from Universitas Airlangga, I'm on behalf of University, I would like to share regarding to the meaningful triplex helix advantages linkage for national innovative development, especially for Universitas Airlangga case study. So now we know all of Indonesian scientists, I think academia, we have the higher education system in our government that will be more based on the outcome based education. So it means this concept is related to the 3 pillars of higher education institution in Indonesia. So we are not only focusing on education, but also research and community services. So for the 3 pillars, we are conducting or developing this one synergistically So this will be more synchronized, the meaning of three pillars of education, research, and community services. So based on this kind of the policy of our government, so then Universitas Erlangga have the strategic implementation by our rector. We call it SMART University. SMART is mean the S, the M, and the A, and the R, and the T is regarding to the sustainability education for all, so lifelong learning for every academia, student, and also the alumni, and of course our also stakeholder in society. And the M is meaningful research and community services, and the A is advancing innovation, enterprising, and industry linkage. I think the M, the A, beside also R, the responsive and lean management, and the T, topic of tangible and intangible resources utilization. So in the meaning of the research or transfer technology in this kind, we also put the M and A, the meaningful, the research community, and advancing innovation, enterprising, and industrial linkage. So I think that technology transfer and commercialization is in this workshop is very, very close related to what Universitas Erlangga also have this policy for implementation strategy. So the M&A is meant to strengthening the meaning of research and community services in supporting the achievement of the, especially on the SDGs. So for this kind of the before we then transfer the technology and also starting the commercialization, we have the the business process, the blueprint of this kind of research and innovation, and also community development in Universitas Erlangga from the input until the impact. So from this kind of the process of this strategy or the blueprint of the research and innovation community development, of course, we have like the idea, so designing the thinking, and then from input from the society or any industry, maybe the issue, strategy, or the problem in the society and our community, our government, and also the industrial. So we then started with the idea, designing thinking with this kind of the roadmap, and also we thinking about market, the problem-driven research and innovation ecosystem, and also the funding. And then after that, the processing will be done directly from the process, converted and forward to be transferred technology to industry or to the stakeholder or policy of the government. So this kind of this business impact from input to impact, we hope that this kind of the process will give only not only the output, but also outcome and the impact of the research. So it can be also the branding of our academia, university by the scientific background and the result of their innovation, and also the transfer technology will be the innovation transfer, and community services becoming the add value of the university, and also, of course, all our city academic in our university. So, of course, the impact we would like to become giving the more impact to our community is not only for the student, like have the learning experience during the study in Universitas Erlangga, but we also would like to give community impact to multi-stakeholder, our government, community, university, individual by the academia, like branding by themselves, have many colleagues from international and national area, and professional association, and also consortium, and of course with the industry. So for all of this kind of the multi-outcome and impact for the community, we are very focusing, like in Indonesia, we also are focusing on the achievement of SDGs, yes. So we try to divide it into 6 topic or 6 focusing on the SDGs is the blue economy, green economy, health, of course, security, digital economy, tourism, conservation, and also the food security. So for this kind of the multi-stakeholder impact, so we should then improving or strengthening our triple helix. I think we not only strengthening the collaboration by the triple helix scheme, like government, university, academia, researcher, and also the business society, but we also now becoming is more from triple helix to quadrihelix with the involving the NGO, non-government organization, but also the mass media. So the mass media is also very important beside government, business, university, and NGO. So we call it that is pentahelix. So how we can do that? Starting from where? So we are have experience now regarding to the pandemic of COVID-19 pandemic. We have innovation in our university to produce the vaccine of COVID-19 pandemic with our industrial partner, and we will start it for the clinical trial in the next of January. I think this one will be the first clinical trial vaccine for COVID-19 in Indonesia. So the innovation is more, of course, important to and then build the idea and also doing the research with the new innovation and also the impact with our community, especially for the during the COVID-19 pandemic. So innovation management at Universitas Airlangga, of course, the same with the, I think the keynote speaker before in our plenary session in the morning, in the this afternoon. So we also trying commercialization by business development and incubation. So we have the board of this kind of business and incubator startup and any other innovation development with the innovation incubator. And also, of course, of this kind of innovation incubator, we develop and improve innovation from the idea to the mass production. So for example, I will also share regarding to vaccine development in our university with the national consortium in Indonesia. And then the important thing also intellectual property rights center. This is protecting innovation in the form of intellectual property. And then the business development in Universitas Airlangga, we develop and improving the teaching industry as the part of like the bridging between the laboratory skill before entering the industrial. So we are improving, we call it teaching industry. So maybe in industry, we call it pilot, yes, pilot scale or middle before the mass production and after the lab scale, laboratory scale. So then after that, we move to technology transfer to the more downstream innovation by collaborating with industry and also the other investors.
Excuse me, ma'am. We actually have 1 minute left.
Okay, so this is the example of Universitas Airlangga. The technology transfer for the laboratory scale to industrial. We have partner Biotis, pharmaceutical industry, developing the vaccine for COVID-19 and will be started clinical trial on next January. I think the first consortium from Indonesia. So we can see here how the technology transfer we did then. So we can look here for the laboratory becoming before the mass production. So the pilot was started in full with our industrial partner. So, but in this scheme, we still also do the laboratorium analysis by genomic surveillance because we know the variant of COVID-19 is look more becoming different and different day by day. Now we have started with the new variant of Omicron. So this vaccine is already success, registered by the WHO. So then why we can start it for the clinical. We have also the teaching industry. I will be more faster. The one we also produce the stem cell metabolite. We have also GLP standard and also GMP for the teaching industry. This is the laboratorium in our University of Stem Cell. We are also producing teaching industry of seaweed hard capsule shell because this is very important. Indonesia is tropical country and this with the seaweed. The seaweed capsule also halal because we are majority of Muslim, Hindu, and also vegetarian. And also, of course, supporting the government. This is the kind of our teaching industry of the seaweed hard hard capsule cell. The third product is glucosamine. This is in Banyuwangi, our marine station in Banyuwangi. We've we developed the glucosamine come from the crustacea. We have shrimp, so many crab, shell, and we can then convert it to glucosamine. The supplement is very important that we are still now imported, especially majority from India. So then this is the production of glucosamine. We started from Banyuwangi teaching industry. It will be together collaborate with PT Fapros Industrial. So the fourth one is allergen extract. This is also important because number of asthma patients in Indonesia is more 12 million people. So it will be immunotherapy factory. It will be the important thing also in Indonesia. So this is our partners, priority our partner from 202 industry from Universitas Airlangga with the Conimed, Kalbe, Kimia Pharma, Indopharma, Fapros, and also Biopharma. And this is our startup. There's also tenant already started from many kind of the alumni and also our student fresh graduate to start with this one. This is the innovator product from Universitas Airlangga, like dental laser, and also for the COVID-19 pandemic of the patient who infected with COVID, we have robotic RISA that will be provided to serve the patient without directly first contact directly with our medical doctor. So this is collaboration with ITS, Institute of 10 November Surabaya, to do the robotic of RISA. This is another medical medicine that we are also produce, like diabetes, and we have also Mediti and Sativa. This is the toothpaste, glucosamine, and also the male contraception. We have also product with industrial pharmaceutical of PT Conimed, and also mood sterilized enzyme, Bagenta, and also Coniderm with Conimax, Eca-Opet, and Petricida, and Balatic. This one is in part of our innovator. So for the research of the COVID-19, we have supporting facility we have teaching hospital, we have hospital special for infection disease, so we'll be separate among the patient of the infected by COVID and also the general hospital. We have also a hospital for mood and also for the animal, which the research of macaca animal in Institute of Tropical Disease, we do for the analyzing of the virus COVID-19 in this area, the hospital and also Institute of Laboratory. We have also BSL3 facility to do the viruses research of COVID-19 and also the vaccine. We have also have the Research Center for Vaccine Technology and Development and already started to continue the clinical trial with the partner of biopharmaceutical of PT Biotis in west of Java. This is the animal BSL3 that we have to do our research with the macaca for clinical trial of our vaccine. And this is for biomolecular engineering laboratory to do the recombinant, any kind of the protein target, also, of course, with the protein of spike and also RBD of the COVID-19. I think this is my presentation. It's very short. I hope that the time is already on time. Sorry, Dr. Manurung. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. I will send back to Dr. Manurung, the moderator.
Yeah, thank you very much, Professor. Unfortunately, we don't have not even adequate time for listening more about University of Surabaya. It should be, for the note of the organizing committee. Sometimes maybe we should learn further from your organization.
Yes,
all right, thank you very much.
Thank you.
Thank you.
Thank you, Dr. Manurung.
Yeah,
Thank
please
you.
stay here.
Yes.
We're going to ask some questions from the audience. So let's move to the next presenter. Thank you.
Yeah, thank you.
Now I'm calling from a presenter from Malaysia. That is Mr. Pierre Muhammad, Dr. Pierre Muhammad from University Kebangsaan Malaysia.
Hello.
Yes. Yeah. All right. I hope you're doing very fine today. So
thank you.
Unfortunately, the organizing committee didn't provide me with your CV. So unlike Professor Nyoman before, I cannot read the summary of your CV. Would you tell us about yourself very succinctly?
Okay, my name is Pir Mohammed and I'm from University Kebangsaan, Malaysia. Okay, currently I'm serving as a senior lecturer at the Department of Chemical and Process Engineering. At the same time, I'm actually managing a chair, okay, which is a niche in the Diabetes Foundation. And my research area mainly focusing on the palm oil industry. So that's it about it at the moment. Thank you.
All right, palm oil industry. That's what
Yeah.
I put on because Indonesia and Malaysia is quite having a very significant position in the world on this matter. So, do you have your presentation material?
Yes, correct.
All right. Would you
Yes.
put it in?
Okay, let me share.
All right. Yeah. All right.
Okay, so
all right. So as you know, we only have, unfortunately, only have 10 minutes of your time today. So please have a go and present it. Thank you.
Okay, thank you, sir. Okay, I was hoping there's about 20 minutes, but now it's 10 minutes. So in that case, I'll be, browsing through quite fast on my presentation. Okay, as I said earlier, my name is Pir Mohammed and I'm from University Kebangsaan, Malaysia. And today I'll be presenting about sustainable integrated palm oil biomass management, a zero waste technology, which is developed by our university in UKM. So the start of my presentation today actually is oil palm. Okay, oil palm is actually a big industry in Malaysia and also in Indonesia. At the moment, Indonesia actually is the largest producer of oil palm in the world, and Malaysia actually is number 2. Okay, and in Malaysia we have almost about 500,000 people. Okay, depending directly on the industry, and about 100 million tons of a fresh fruit bunch actually been exported out by year 2020. So basically, oil palm is a big industry in Malaysia, and our plantation actually largely monopolized by oil palm. So as I said earlier, okay, Indonesia is the biggest country in the world for producing oil palm. Malaysia is the second, and Thailand is actually in the short third. And together, this region, Southeast Asia, okay, actually accounting almost 90% of the total world oil palm production. So oil palm, whenever we talk about oil palm, actually is referring to the tree called Lens guinensis. Okay, it's actually not local for our region. Actually, about 80-meter height. Okay, so if you have a chance to visit Malaysia or you visit Indonesia, the chances for you to have a look on the palm oil estate is very high. So a palm oil tree, okay, they almost look like it's like a distant cousin to the coconut tree if you have not seen a palm oil tree before. So, and the main idea of this plantation actually is for the palm oil fruits, which is we call it FFB, fresh fruit bunch. Okay, and this is a typical picture of a palm oil mill. Okay, so usually we have about 20 ton per hour up to 200 ton per hour, but a typical size of a palm oil mill production is about 60 ton per hour. Okay, and usually the process actually focusing more on the use of physical and also physical and thermal kind of extraction, and the whole process usually is carried out by chemical-free method, and it's quite great because the whole system is really running by biomass power, okay, which is actually obtained from the palm oil biomass stuff. Okay, so let's take a look what is the oil palm biomass. Okay, when we talk about oil palm biomass, we're actually focusing on the main idea, okay, which is the palm fruits, okay, FFB, fresh farm bunch. And then usually, okay, as I said, this is like a distant cousin to the coconut. Okay, you can actually can relate to coconut. Okay, so it will look like a coconut. Okay, a single fruits. Okay, from the total bunch we call as a palm fruitlets. Okay, and this palm fruitlets we can actually separated into 2 parts. Okay, the first part actually the outer layer we call as a mesocarp fiber. Okay, and the inner layer actually is the palm kernel. Okay, the outer layer.
I'm sorry, but the audio.
Which is the mesocarp. Okay, will yield to the palm oil normal. Hello.
Yeah, it's been going normal. Sorry.
Is it okay?
Yeah, it was intermittent coming from your side.
Okay.
The
So
audio. Okay.
the outside, okay, the outside one, okay, give to the palm oil. Nice. Is it okay now?
Now, yeah, but it's coming and go.
Hello, hello.
It's coming and gone. Your audio.
Okay.
To hear me.
So we have two types of oil. Okay, one is we call it palm oil. Yeah, I can hear you. I can hear you. Can I continue?
Yeah, please do so. I didn't say anything actually.
Okay. Okay, so the oil is only accounting about 10% of the total production value from this typical tree. The other 90% actually is a Mesoka fiber, palm kernel, palm kernel shell, set of four products, okay, which is produced during the extraction of palm oil meal. At the same time, another oil is of the total oil is actually what the industry actually focusing at the moment, while 90% is actually still used for very low valued applications. Okay, so other than that, okay, the palm oil mill also lead to the production of a wastewater, which called as a palm oil mill effluent. In short form, we call it POMI. So this industrial scale wastewater very high level. So and usually produce okay and issues and challenges of the industry. Okay, this industry requires a lot of water. Okay, so typically 1 ton of the FFB, okay, up to about like 6 ton of water, and they use a lot of electricity. Okay, and do the utilization of for the process. Okay, they will lead to the production of carbon dioxide. Sometimes there's black the boiler, and when the palm oil FFB entered the system, okay, we produce a CP oil, and will produce a palm kernel shell, which is the outer layer, and also will produce a lot of biomass, okay, which is known as pomate, okay, and the pomate is actually a very high strength wastewater, and in the traditional way, okay, the mill usually using to actually treat this pomate and can lead to the what they call emission of a methane gas, a control methane gas. So methane gas actually is a very important greenhouse gases. Okay, and these are the industry at the moment. Okay, so but the thing is, okay, when we take a look again, we revisit again the oil palm biomass. Okay, we notice one thing. Okay, even though the oil palm biomass actually been produced a lot, okay, at the moment they're still underutilized. They use what you call low valued application, but with the crucial testing and analyzing, we found out this oil biomass are very rich in sugar. So sugar is basically like the central chemical platform for a lot of biological process. So we take this composition, okay, as an opportunity for us, okay, and try to come up a better solution, okay, for the palm industry. And our solution that we actually developed over about 15 years in UK, zero waste technology pilot plant for palm oil mill. Okay, and this one was actually jointly funded by the university and also by Sime Darby. Okay, Sime Darby is actually one of the biggest plantation company in the palm oil industry, both in Malaysia and in Indonesia. Okay, so they seed funding money, okay, since 2011 to develop our research, okay, to try to find a solution for this palm oil mill and also the palm oil mill biomass as well. So with the money from the, okay, we managed to build a pilot plant. Okay, and this pilot plant has been operating since 2017, and we treat both the liquid and solid biomass for the mill. Okay, with the 5 integrated area. Okay, we actually managed to produce the bioenergy. We managed to recycle and reuse the water, and also we come up with a solution for sustainable solid management. And the feedstock, okay, we, as I said, we focus on 2 feedstock, the waste on the empty fruit bunch, the solid feedstock. Okay, so we did the characteristic for both and also as I said, for me, the CD value can range from 16,000 up to 100,000. It's a big. It's also opportunity to try to utilize them. And lignocellulosic material, okay, and especially glucose and xylose, it's a very attractive chemical processes, but they come with their own challenges. Okay, so with the thing, okay, over the time, so we research in UKM, okay, and then we translate it into a pilot plant. A pilot plant focusing with the 5 different area, okay, and area have their own focus outcome. So this is like a general, like a flow map, okay, for what we do in. So basically, we focusing on the waste from the palm oil mill, okay, which is formate. Utilization is slightly different from the one. They were focusing on the biogas, okay, which is specifically referring to the methane gas. But our industry, our technology, we actually focusing on the hydrogen gas and also methane gas. So we managed to produce hydrogen first, and then followed by methane, okay, and then this hydrogen we purified them and for the electricity using a fuel cell technology, which is UKM. What they call the liquid, okay, for the digestion, we further use it to cultivate algae. So this algae act as like our carbon sink. Okay, they actually use to absorb our carbon dioxide and other emission which is produced throughout the process. And at the same time, we produce algae, and the finally effluent actually used through the membrane. Okay, further polishing, and we recycle back to the mill specifically. And while the solid biomass, okay, specifically active lunch, we use a biomass treatment technology using what we call high temperature and turn up the structure of the fruit bunch, okay, and we managed to extract the sugar. And this sugar, again, we feed it to a hydrogen reactor to produce more hydrogen, okay, and to produce energy for the palm oil mill. This is our solution, okay, which we've been doing in our pilot plant for the last, okay, compared to other innovation, okay. Hydrogen actually has a higher specific energy content, okay. That means 1 kg of hydrogen has a very high energy content, even with the other available energy carrier. At the same time, it's a clean combustion. If you burn hydrogen, you don't get any CO2, you only get water and energy. At the same time, we can use the hydrogen directly to electricity using a fuel cell technology. Okay, so this is a very clean energy with a high what do you call conversion level. Okay, if it's a typical gas engine, you can get about efficiency about 35% recovery. The fuel cell, you can go up to 60-70%, okay, of energy recovery. So that's why we actually promoting hydrogen as our main carrier in our project. And the most interest actually coming in back since 70s. Now hydrogen is actually been getting a lot of interest. Okay, so this is okay. So this is an actual picture which we take in our pilot plant. The actual picture which we take now. Okay, so we have the first, and then okay,
Dr. Pierre, is it okay with you with the voice streaming? Yeah, unfortunately, we cannot hear you clearly. Dr. Pierre. Dr. Pierre, is it okay with you there? All right, so unfortunately, we don't get any reception from Dr. Thea to the organizing committee. I'm asking for your permission to move on with the next presentation. I'm sorry, Dr. Pia, but it seems like we need to move on with the next presenter.
Hello?
Yeah, can you hear me? Is it?
Yes, I can hear you.
Yeah,
Yeah.
yeah, but unfortunately, we don't get a smooth voice streaming coming from your side. Well, it was, you know.
Okay, in that case, stop my presentation. Is it okay?
Yeah,
okay, thank you for the
I don't
organizing.
think, yeah, so sorry for that. That was a situation that we have to take on. All right, now, well, I'm sure it was very interesting. I'm personally very interested in palm oil research. Nonetheless, I think it's better for us to move on to the next presenter. Thank you very much, Dr. Pia Muhammad, for your very strong material. Now we are inviting Dr. Danis Eka Prasetya Wijaksana from BRIN, my colleague. Are you there? All right. Oh, yeah, I see you. So how are you, Dr. Danis?
Yeah, great. So great. Thank you very much, Dr. Manurung.
Okay,
Yeah.
okay, okay. Now you are the third person speaking. You should know that our available time is very short. Regardless, I'm asking you very self-introductory for us. Could you tell us about you?
Yes, thank you. Okay, first time I would like to introduce myself. So my name is Danis Eka Prasetya Wijaksana, and actually I'm not a doctor yet. Maybe it's kind of typo from the committee. I'm still just an undergraduate student, and yeah, I'm not a doctor yet. I was graduated from Universitas 11 Maret, and now I'm working in the National Research and Innovation Agency, or BRIN of Indonesia.
All right.
That's enough.
Okay, that's good enough. So we receive the information that you are going to present framework system of university technology-based startup development by university incubator case study. So do you have your presenter material today?
Yes, I do. Can I
display it? Okay.
Okay.
All right. I'm sure your presentation will be excellent, and it will be even more excellent if you can deliver it succinctly in 10 minutes. Now, please have a go, and I will calculate. I mean, I'm going to keep up your time for 10 minutes availability once you start it.
Yes.
Thank you.
Okay. Thank you very much. Is it fine?
Very, very fine.
Yeah. Okay. Thank you. I'll just I want to start my presentation, so I would like to tell about one of my research entitled Framework System of University Technology Based Startup Development by University Incubator case study. So to make it concise, I will just go straight forward. Our agenda, maybe there's not a lot of things that I would like to discuss here in this occasion. So I will just tell about what we've done in our research and what the result. Let's continue. The first, I would like to introduce the paper. So the framework system of university technology-based startup development by University Incubator of Case Study itself is actually a paper that based on a thesis, my thesis actually, and it has been published in international conference on industrial engineering and operations management in Bangkok, Thailand, 2019. And actually it has been about 4 or 5 years ago the research has been conducted, so maybe it's a little bit out of date about the material of the research, but because today the first day we will examine about the common technology transfer mechanism, so I think it's still very appropriate. And firstly, I would like to introduce about the case study. So in this paper, we examined about PIT in UNS. What is PIT in UNS? PIT itself is Pusat Inovasi Teknologi of Universitas 11 Maret located in Surakarta, Central Java, Indonesia. PIT is a university incubator that aims to promote universities' role as shifting into technology transfer process as a part of regional economy development. And the establishment of PIT UNS itself was designed as an incubator, so the academician of UNS can transform their research output to become a startup or company or even other commercial form. The PIT itself has been established since 2014, but the research is also conducted in 2000 and around 2015, late 2015 or 2016 also. So there were still some issues. For example, it is still quite a new concept in Indonesia where a university have a technology incubator to create and develop a technology-based startup. Usually, university in Indonesia have so-called as maybe like I don't know, like you need to develop the SMEs in university, but not specifically designed it for technology-based product. So in early 2010s, including 2014, there were not so many examples of university technology incubator in Indonesia. So we have to dig deep to get a best practice examples in Indonesia. And of course, in 2016, it's still in early developing stage of PIT UNS. And we need to develop the business process and the activities there so we can achieve and obtain the goals. And because the early developing stages, we still have lack of documents or maybe basis to conduct our activities and process, because there were no official and specific SOPs about the activities that need to be done so we can achieve what we are pursuing in PIT UNS. And also the exit strategy, there are no many alternative exit strategy in PIT UNS on that time. We are still focusing on creating technology-based startup and for a company, but of course, not all of the technology product can be commercialized in company, but sometimes it can be in joint venture or license or maybe strategic alliance. But yet, it's still not. It hasn't been formulated. From this background, well, we started to do our research, and we start from initial identification. What is the initial identification? So we identify what is the general business process of PIT-UNS. The general business process will be used to create, to decide, to determine what will we examine to develop this the PIT-UNS. So PIT-UNS can help, can assist all of the academician in UNS itself to obtain the technology-based startup, and then of course to promote the regional economy development. And then after we conducted the identification of general business process, we determined the activities that will be examined. We done a benchmark study about the technology-based startup development in other incubators. There were 3 incubators that we examined. We will talk about later in the next section. And then the two first steps are combined to formulate the framework system about the technology-based development process in PIT-UNS. The system that has been more formulated will be used as a basis to create the SOPs, the necessary SOPs, and how we can rearrange each of SOPs one into another. So we can, the SOPs will be very beneficial for all of the stakeholders that are related to the PIT-UNS, including academician itself, or maybe the stakeholders from outside the UNS. After we formulate the framework system and the SOP, before we implement it and apply into the real case study, we can kind of pre-implementation by using the case study with 2 very first tenants of PIT-UNS, sorry, and conducting a focus group discussion with managers team of PIT-UNS, so we can get feedback and recommendation about the improvement of the framework system or the SOPs, or maybe everything detail about the PIT-UNS, so we can develop the organization not just based on the general business plan or maybe just a master plan, but we have a really detailed planning and what is it, technical yeah, technical ways to achieve our goals. And then after we get the feedback and recommendation, we done an analysis. We compare the 2 conditions between the previous condition when the existed condition of the PIT-UNS, when we still use the basic and general business process as a basis to conduct our activities, and then with the SOPs and all of the aspects that have been determined and formulated based on our studies. And what about the result? Let's continue to the next section. So this is the first initial identification from the literature study and field study of 3 incubators. We identify that there are several of activities that need to be examined in university incubator, especially to create a technology-based startup. Yes, maybe all of us know that there are 3 main steps in incubation process. There are pre-incubation, incubation, and post-incubation. And we divide it into 8 steps. 1, 2, 3, 4. Yes, 8 steps. Sorry, it's 9 steps. But we eliminate the production and consumption and selling test because it's too technical, and the variation of the tests are really wide. It depends on the characteristic of the product, because Universitas 11 Maret itself is a big university with a wide range of field. So yeah, we eliminated it into a next study. And then we decided there are 7 main activities need to be examined. There are tenant selection, mentoring training, certification and license and IP protection, funding, partnership, monitoring and evaluation, and then the final step is exit strategy. After we determine the 7 main activities, we conduct the benchmarking study. So the 7 main activities, we make it more detailed for what target that will we need to achieve in benchmarking study and every activities. Well, it's still just a brief of benchmarking target. Actually, if you you are interested in more detail about the benchmarking target, you may check the paper itself. You may browse it online. I think it's available online and free. And we conducted in 3 benchmarking subjects. The first one is Balai Incubator Technology in BPPT. It represents the incubator managed by governments as a regulator in Indonesia. And then the second is LPIK ITB. It is a well-established technology incubator in a university in Indonesia. It has been established since 2003, and I think it is a perfect example for PIT UNS to develop and create the appropriate system to create technology-based startup based on their research output. And then the third subject is Innovation and Commercialization Center of University Technology Malaysia. ICCUTM will represent as incubator conducted by overseas university, but still in developing countries. So yeah, maybe I will not explain it in detail about the result of the benchmarking studies, but maybe I'll
Yeah, actually, we are running out of time. Sorry,
Okay.
It will be appreciated if you could make to the main point. Thank you.
Okay, yeah. This is the example of the studies. They are after we done the best benchmarking study, and then we decided what the best practice for PIT and UNS, and then what is the justification, and we determined there were 8 main SOPs need to be created to be formulated in this framework system. In formulating framework system, we use the system approach. We use the input, process, and output IPOs approach. So for example, in tenant candidate selection, we examine the input elements. What we have to determine, what we have to make it clear, just in detail about the input, and then how is the process. The process is determined and examined based on 3 incubators that I have mentioned before, and then the output, well, I think generally the output is just same between the PIT UNS and the 3 incubators. And this is the general result of the framework system from the very beginning, from the tenant candidate collection, and then until the exit strategy. It depicted all of the process, the input, process, and output. The process itself will be detailed in SOPs. And then we continue to the analysis. So we compare the existing and proposed condition of framework system in PIT UNS, and then we analyze what the advantage that we got from the proposed system in our research. Well, generally speaking, a lot of advantage except for boundary, because yeah, we just can broaden our boundaries. And yet, as I mentioned before, that we still use the system approach. And then the last analysis, we use 5M analysis: man, material, machine, method, and money. In each category or elements, we examine what is the strength or weakness of each element and what can be done to improve all the elements. So it can be strengthen the existence of PIT UNS, and then of course can promote to pursue and achieve the goal of PIT UNS. But I think that's all my presentation. Thank you very much.
Okay, thank you very much, Mr. Dennis. Okay, well, thank you. We need to move on with the next presenter. Thank you very much for your material. Thank you. Right, now I'm calling Ms. Meenakshi Kanawija from India. I was told by the organizing committee that Ms. Meenakshi Kanawija is ready. Right. I'm apparently not. So I'm calling for Dr. Subendu Chakrabarti. Oh, okay. So my apologies. Dr. Meenakshi, Ms. Meenakshi Kanojia, I'm sorry for not able to pronounce your name correctly. Hello, are you there? Okay, I believe your speaker is still muted. Ms. Meenakshi?
Yeah, I'm very much here. Am I not audible?
Now you are. Now we can hear you. All right, so I was told by the organizing community to ensure that every speaker would be so kind to make a self-introductory. Would you do that?
Yeah, sure. I'm Meenakshi Kanojia. I'm from Amity University, Uttar Pradesh, India. This is a leading private sector university in India, a research and innovation driven university. And I'm working as an assistant director in University Technology Transfer Cell. That is Directorate of Innovation and Technology Transfer. I have more than 12 years of experience in establishing industrial academia linkages, particularly looking after transfer and commercialization of technologies from the university ecosystem and establishing R&D based collaborations with the industry.
Right.
And I'm a registered technology transfer professional as well.
All right, yeah, brilliant. So would you turn on your video? So
I'm not able to. I think there is a glitch in my network. So if I switch on my video, I won't be able to. You won't be able to hear me.
I understand. All right. So I'm sure you've learned that the time available for speaking is very short. That is 10 minutes. So I hope you attend to the very limited space for you to present your material. And I will count it out. I mean, the consumed time for 10 minutes right after you commence speaking. Okay, the time is yours, ma'am.
Okay, so shall I start?
Please do.
Yeah, sure. So I'm going to present a case study of one of the private sector university. I'm going to present leveraging technology transfer from higher education institutions. See, since 1991, so Indian liberalization and globalization policies have been mainly focused at increasing exports, foreign direct investments, and creating the competitive environment for improving the efficiency and productivity of the system. So Indian industry also restructured itself to meet the emerging growth challenges and the competitiveness in international markets. The economic reforms after 1991 and emergence of World Trade Organization in 1995 and other foreign trade mechanisms provided easy access to foreign technologies for the industry. So accordingly, the technology transfer models also undergone notable transformation from import of second or third generation technologies through third turnkey projects and re-engineering or Indianization of research and development efforts to inflow of modern technologies with foreign investments.
Ms. Meenakshi, could you make your slide full screen? All right, thank you. Please continue with your presentation.
So the government of India has also come up with several schemes and support system for enhancing the rate of technology transfers. So there are lots of studies available, but most of the studies are focused on from the developed countries perspective, like in this like particularly in this research work, we have focused on reviewing the literature related to technology transfer, and most of the work has been focused on the developed nation, or if we talk about the India, it is mainly focused on the public sector organizations only. And the major in this paper we have focused on the private sector higher education institution, and one of the major problem which we found in the technology transfer is we all was with that all the higher education institution, particularly in the developed nations, are suffering with this like low level of technology transfer and commercialization from academia to industry. So this is the Indian overview. Like I have already said, that various scientific departments like Department of Science and Technology, Department of Biotechnology, IC, and Indian Council of Agriculture Research, Ministry of Science and technology. So these are some of the government departments from India, and they have evolved several programs to promote and support development, transfer, and commercialization of technologies. But the problem is most of these problems have aimed at developing new technologies and capability building in public funded institutions. So these government funded R&D projects generally result in development of technologies at laboratory scale only. And this is the reason most of the technologies do not get transferred to the industry because of their low maturity level of the technologies. Therefore the commercialization and when these like products gets developed in the higher education institutions, their commercialization are mainly dependent upon the institution, which do not take place in significant manner due to the lack of awareness, skills, and financial resources. And Government of India has established NRDC, like National Research Development Council, Biotechnology Consortia Industry Limited. Like these are two government setups which are being established by the Government of India, which are looking for the transfer of the transfer of these technologies, which are getting developed in the national laboratories of the India. Like BCIL is particularly looking after the biotechnology related technologies, and NRDC is particularly looking after the CSIR, that is Central Research Industry Council. This is the like government organization, and there are several labs, around 36 to 37 labs comes under CSIR. So NRDC is mandated. Initially NRDC was mandated to look after the transfer and commercialization of these of the technologies of CSIR. And now NRDC and BSIR both have extended their operation. Now they are looking after the university technology transfer as well. So the commercialization of the technologies always remained a concern. Then further, IITs is that set up, like Indian Institute of Technologies in India, they set up their own technology transfer offices and have been fairly successful in commercializing their technologies. So government of India remodel the existing schemes just to overcome these the major drawback related to technology transfer, and they come up with new schemes particularly targeting for individual innovator R&D institution, universities and institutes, industry. Mainly if the R&D proposals are in partnership with industry, or if the funding dries up after the project is completed at lab scale technologies. So what is the remodeling, or the earlier the schemes for the development of the technology, now the government of India have come up with the schemes which are for the further scaling up or the validation of the technology, scientific leads which have generated out of the basic research in higher education institutions or the R&D institutions. So public funded institutions and universities are still supported by the government for commercialization of new proposals, for commercialization if new proposals are made. And the availability of the financial support for technology transfer and commercialization activities in private universities continues to be a challenge. So the main problem is all these government schemes, they though they support private universities, but still private universities are lagging behind to get the government support. So some of the leading universities in public and private sector are encouraging R&D, but it requires proper support. So these are some of the government departments, those who have initiated the schemes for the development of the technologies, like DSIR and ICAR, MSME. So government has recently come up with the technology mission division as well. So for water technology initiative program, clean energy research initiative, nanoscience and technology mission. Now I'm going to give the case study of the Indian private sector university, which is an Amity University. So Amity University was first established in 2005. So presently in 2005 in Noida itself, that is Uttar Pradesh. Presently it has 11 university in India and abroad, one university in Dubai and another one campus in USA as well. And it is a research and innovation driven university. Uh, uh, Presently, it has filed more than 1,600 patents. So you can see the ratio of the patents in which the patent applications have been made. Like if you can see like engineering and technology. So this is the very diversified portfolio. The university is focusing on almost all the areas. Pharmaceutical sciences is the one which is uh, the foremost area on which the researchers are focusing. So it has a very structured innovation ecosystem. So it has innovation incubator, which is being supported by the DST, technology enabling center, again supported by Department of Science and Technology, Government of India. Under this center, the basic leads which have been generated during the basic research carried out by the scientists in the university, this technology enabling center is helping these researchers to further increase the readiness level of the technologies, so that the technologies reaches to certain level of maturity and would be where their prospects for the transfers increases. So we have Institution for Innovation Council, which is being supported by Ministry of Higher Education, and we have Amity University have intellectual property cell as well. It is an in-house intellectual property cell. The cell is looking after like filing, not only filing but advising and supporting the researchers as well to come up their new innovation. They help the researchers to formulating their applications and highlighting the marketability of the product. We have an innovation and design center as well. So this center is dedicated for making the designing and making the prototype of the science and technology related technologies. And there is another very important organization structure, which is the University Technology Transfer Office. This is the office which is responsible for bridging the gap between the industry and the academia, particularly related to R&D endeavors. So this department is looking after the transfer and commercialization of the technologies, like right from the assessing of the innovation, and then valuation, negotiation, bringing industry to the researchers, providing the common platform for the discussion. And so this is the department which is responsible for all the R&D related outreach activities. So these are some of the technologies which the researchers from the Amity University have transferred to the industry. So one technology is the herbal mosquito repellent. So it is a low-end technology, but this is 100% herbal technology. No chemical has been used, and this technology has been transferred to 3 MSME companies in India. And the next one is the electricity generation and wastewater treatment technology. This is particularly the technologies where we can generate electricity while treating the wastewater. And this we have recently transferred to another medium-sized company. And what we done in this technology is research. This was the project funded by the Department of Science and Technology. So the basic research was conducted with the help of the Department of Science and Technology, and the scientists were able to develop a lamp. They were able to light a lamp through the government support. So after developing the lab scale model, then the role of technology enabling center comes into play. So technology enabling center supported the researchers to increase the maturity level of the technology. So technology enabling center provided technical and the financial support, and provided all the enabling ecosystem to the researchers so that they were able to light tube light in a lab. So when then the university technology transfer started working for the licensing of this technology, and many industries like companies showed interest in this technology. So one of the Pune based company the university finalized to license this technology to a Pune based company, and now the further scaling up of the technology is under progress. And
unfortunately, the time is already passing 4 minutes from 10 minutes mark.
okay,
Would you make it? Yeah, all right.
Sure. I got your point. So similarly, we have transferred other technologies also, like Rutonic. This is the plant growth promoting microorganism. This technology has been transferred to a Taiwan-based company, and we are like dealing with a Canada-based company also. And in India, it has been transferred to 4 MSMEs and 3 startups. Similarly, herbal hand sanitizer and herbal floor disinfectant. So what I am trying to convey a message is like we are particularly looking for non-exclusive licensing. Being an academic institution, we are working for the development of the society, but it is not like we are limited to non-exclusive license only. So because we have to generate the revenue also for the operation of university technology transfer office. So we are working on a limited exclusivity basis on the basis of the geography and the timelines as well. So these are some of the negotiation strategies which I'm trying to convey. So while during our study, we have learned some cases, and these are some of the concluding remarks based on our learnings. So what happens is in the India is particularly the organizational structures like technology transfer office, IPR cell, incubation incubator are not in place in most of the universities, which we recommend need to be set up. And industry academia relationship and interactions are found to be weak and need to be strengthened. So this can be strengthened through several ways, organizing the industry academia meets on regular basis, industry clinics, and by participating in the organized exhibitions, and having membership of the chambers like uh, CII and FICI and all. I am talking about in perspective of India only. So there are certain universities, particularly in private sector, generally they lack financial resources, IP strategies for research and technology transfer commercialization. So lack of IP awareness, special programs need to be launched in this respect. And one of the one another important learning is the training and skill upgradation programs need to be organized to develop professional capabilities in the area of technology transfer and commercialization. See, from the experience at Amity University, Noida, a private sector university, we have learned that there could be a sizable technology transfer and commercialization activities in the universities, but provided the support and commitment at the highest level is available. And some like cutting edge technologies need to be developed for visible outputs. So right at the time of filing the patent, or right at the time of doing initiation of the research, the researchers need to be very sure about the commercial aspects of the technology if they're targeting for the transfer of the same or for the commercialization of the same. And the government program should speedily operate with sufficient funds available for the projects from the startup of the R&D project to technology transfer and production level, so as to reach the end products to the market.
Right.
So that's all. Thank you so much.
All right. Thank you very much, Ms. Manas, for your interesting presentation. I think from your material, we can understand that developing economies are actually not very different in their problem from one another. So that shouldn't be an excuse for one actor in developing economy to feeling discouraged, because they're actually not very unique in dealing with the ordeal occurring in their own nation. Right. So now thank you very much for your material. Now we are going to receive a presentation from Dr. Subendu Chakrabarti. My apologies if I don't mention your name correctly. Could I invite? Dr. Subendu?
Yeah, good afternoon.
All right. Yeah, good afternoon, sir. Yeah. All right. So the organizing committee asked me for you to make self introduction very succinctly. Would you do that? All right.
Yeah, thank you. I'm Dr. Subhendu Chakravarti, basically a leather technologist by training. I've been working in CSIR, Central Leather Research Institute, Chennai, which is the largest leather research organizations in the world. I'm working here as chief scientist. My work area is predominantly in the area of IP protection and, of course, project and technology management and technology transfer.
Interesting.
Yeah.
All right. So perhaps you've seen before that we only, we all fail impossible time limit, that is 10 minutes. Unfortunately, that's given. You do this. Okay. So you've seen it. So would you make it full screen?
Yeah. Yes. Yes. Of course, I'll try to do that.
All right.
Is it visible? The slides are visible.
Yeah. Very good. So I'm going to start counting your 10 minutes, if you can, right after you begin speaking. Please do, sir.
Okay, fine. Thank you. I deem it my pleasant privilege to have this opportunity to first participate in this esteemed international workshop on technology transfer and commercialization. I take this opportunity to congratulate NAM SNT Center, New Delhi, India, and BRAIN Indonesia for organizing this very timely workshop. The relevance of this immaculate and judicious topic is immense for this technological growth and sustenance of human civilization. Generally, while talking about technology transfer and commercialization, what immediately comes to our mind is licensing agreement involving conditions such as exclusivity, licensing period, jurisdiction, financial terms involving lump sum royalty, then infringement, legal remedy, etc. That we witness in sectors such as drug, software, etc. It is interesting to see what happens in a traditional sector. I therefore take this opportunity to share my observation and experience in the realm of technology commercialization in traditional sector with special reference to leather sector. Intellectual efforts of mankind results in valuable knowledge products, which essentially provide viable technical solutions to existing problems and help the human civilization to progress. It, however, necessitates transaction, diffusion of the generated knowledge, either IP protected or otherwise, to the society that uses solution and provides feedback as input for further research. Having spoken about knowledge products, we recognize that this may be of different types. Modern research generates scientific knowledge that may be translated either in IP protected or open access mode. But there is another component of our available knowledge that percolates down the generation in a community. This is traditional knowledge that plays a major role in providing unique solutions. Unique feature of traditional knowledge is its inclusive nature and sharing, resulting in an informal knowledge transfer for an unlimited period. Propriety and use are likely to be restricted to the community concerned. Lack of documentation is, of course, a major constraint in such case. On the other hand, knowledge-driven industries essentially depend on modern IP-protected knowledge, whereby the IP owner transfers the right to use the technology under certain terms and conditions without sacrificing the ownership in terms of what is called licensing, which is more of formal transaction. These are normally well documented and pave the way for further R&D to promote new knowledge generation. With the advent of the WTO in the year 1995, there has been a paradigm shift in the global socio-economic framework, which has become more knowledge-driven. The world today witnesses the emergence of an era that relates knowledge to economy. Thus, the ability to strengthen business with updated knowledge resource is believed to emerge as a feature of global competitiveness. This is quite evident from the different IP wars, especially in such industries as drug, considering that the very nature and feature of the traditional industries vary significantly from those of knowledge-driven industries. It is a matter of immense interest to see how the traditional industries that form an integral component of the socio-economic framework readjust to the changing demands of knowledge economy. Any industry that is rooted in traditional practices involve informal transaction of technology and knowledge is faced with a need to readjust the changing facet of the IPR world. Leather industry happens to represent a tradition-bound industry with its impressive presence in the global trade. In this context, a case study on the technology translation in leather sector gains interest. History of leather industry is hidden in the mists of antiquity. It has conventionally been characterized by its feature of traditional form of knowledge creation, sharing, and exchange. It has depended heavily on the informal innovations. Trade secret approach has essentially been the conventional protection mechanism for knowledge base in this sector. Prevalence of essentially informal innovation and resistance to adoption of new knowledge lead. That gives to larger technology life cycle. Nevertheless, it has been a major player in the global trade with an impressive share. But it is confronted with several multi-dimensional threats, such as stiff competition, technical barrier to trade that pose major challenge to the industry. Sustained innovation and formal modes of technology translation gain importance in this context. It was a judicious decision of the policymakers in India to establish a national R&D laboratory for the benefit of the leather sector, and CSIR, Central Leather Research Institute, was born in 1948 as a constituent laboratory under CSIR, Government of India. It has been enabling resource for the technological empowerment of the industry by working in tandem. Empowered with vast strength of manpower and infrastructure, it is a unique storehouse of knowledge and skill. The Institute has emerged as the most significant patent filing organization in the leather world. It strives to empower the industry using different modes of technology translation. Models for technology transfer and commercialization thereof involve essentially a mixed bag. Industry works predominantly in small or medium scale sector, and hence licensing conditions are decided on case-to-case basis. Startups are extended certain privilege as motivational measure. Traditional nature of the industry predominantly necessitates technology push strategy for the knowledge translation, although market pull strategies become relevant at times. For example, for combating any challenge posed to the industry that becomes relevant when restrictive practices, including closure, are ordered by the statutory authorities for non-compliance of essential environmental standards. So market pull strategy also becomes relevant when contract R&D is undertaken in an area of interest of the user industry. Technologies are transferred either directly or through a technology facilitator for faster commercialization. Leather making, which essentially involves chemico-mechanical operations, relate predominantly process-based system practiced in clusters. So individual licensing is welcome, but cluster approach attains priority for translating process technologies to ensure better diffusion of the technology, leading to successful commercialization. Product-based technologies are, however, licensed on negotiated terms and conditions, while licensing technologies, the know-how is demonstrated, personnel of the licensee are trained, a document providing all details will be provided, and hand-holding and troubleshooting is extended for successful implementation and commercialization on mode of relationship model. It is also pertinent that CLRI brand is extended to the licensee to facilitate commercialization. By and large, the licenses are granted on non-exclusive basis. Decision on limited period or otherwise exclusivity, if required, is taken on case-to-case basis with a safeguard to ensure that the technologies are not abused. Another model involves technology intervened upgradation of traditional process and translation of the improved technology through capacity building and artisanal skill upgradation. Assistance has also been extended to seek GI protection for such products. This has enabled empowerment of the traditional artisans for making better quality vegetable tan leather and kolhapuri chappal. It is pertinent that successful commercialization of the technology on kolhapuri chappal on global platform has paved the way for gaining significant attention of the global market, leading to successful trade return. It is also pertinent that vibrant commercialization has led to betterment of livelihood of the community involved therein. To summarize, a study undertaken in CLRI has revealed that the advent of WTO regime seems to have promoted the patent fencing habit in the leather world, potentially implying a transition of the sector towards the formal technology transition model. The rate of transfer of the patented knowledge laid by CLRI for the benefit of the user industry is significantly higher than that of global average. The analysis indicates that the technology and trade in leather are not yet linked very strongly. An industrial sector like leather, where practice precedes understanding of the principle, witnesses a lag between the potential strength of IPR and ability to gain large market share, implying a very weak technology trade lead. It is pertinent that factors promoting success in commercialization include technology outsourcing ability and developing market niche through brand building. Knowledge network involving partnership among R&D, academy, and industry with defined roles gain importance. Industry has to integrate national R&D resource into its business strategy. R&D labs need not be seen always as supermarket for off-the-shelf technology. Thank you. Thank you very much.
Thank you very much, Dr. Subandu. It was very succinct. You actually didn't go the 10 minutes mark. So I congratulate you for managing the impossible time limit. Thank you very much. Thank you. Okay, so we are asking you for permission. We are moving for the last but not least presenter, if you don't mind. Thank you, sir. Right, so, okay. So we are asking for Dr. Huda Nito, senior lecturer, micro. Sorry. Hello.
नहीं अभी नहीं निकले.
Okay. All right. So that's a leak. We are asking for Dr. Huda Nito, senior lecturer in microbiology, University of Mauritius. All right. So okay. All right. So Dr. Huda. The organizing committee will ask me if you could put on your video, if you don't mind.
I believe my video is already on.
Oh, all right. So yeah, hello there. Thank you very much. So you know the rule, the time of validity is very stringent, only 10 minutes. Okay. So I'm going to calculate your presentation time right after you begin speaking. Please.
Cool. Thank you, moderator. And I hope you can see my screen. Yes.
Very well, yes.
So, good afternoon, everyone. Right now in Mauritius, it's around 1:30 Mauritian time. So my name is Huda Nitu, a senior lecturer in microbiology and food science. And I would like to take this opportunity to thank the NAM S&T Center, as well as the BRIN Indonesia, the Research Innovation and the National Research and Innovation Agency of Indonesia for hosting this workshop and giving me the opportunity today to showcase our research. So this research, which I'm presenting on the slide here, is an innovative line of breakfast cereal product termed Smart Bite Manudix, which has 6 core attributes nicely summarized in the acronym HEALTH, where health stands for something which is helpful, really good for your health, easy to use, affordable, low in fat, tasty, and really high in protein. And the reason which stimulated our team to go on and do this research is because in Mauritius, as well as in all countries worldwide, breakfast is considered the most important meal of the day. And paradoxically, breakfast is also the meal that is most missed, not only among students, but also among many working individuals. And yes. And before we actually go any further, we need to understand the food and nutrition security status in Mauritius. I know this was mentioned by the second speaker, that food and nutrition security is an important axe of research. So what is food security to begin with? Well, a country is said to be food secure when everyone at all times have sufficient, safe, and nutritious food, and they have economical, physical, and social access at all times to this kind of food. But unfortunately, Mauritius, like many other small island developing states, we are plagued by the triple burden of malnutrition. So not only undernutrition, but also micronutrient deficiencies and also obesity and overweight. And from the latest statistics, 50% of the Mauritian population is currently overweight and obese. So that is not good news at all. And so in an article that we published, our team of researchers, we call them the Smart Bite team, we published an article in a local newsletter to precisely mention that academics and researchers, we have a great role in addressing the food and nutrition insecurity problem in Mauritius through both research and outreach. So let me tell you a little bit about our Smart Bite journey. So let's go back from the beginning. It all started back in 2016 when my colleague and I, we noticed that a lot of students coming to campus were coming in the lectures in the morning without having had breakfast. And as soon as lectures were over, they were all heading to the canteen and eating a bunch of products which were high in energy, so energy dense and yet devoid of nutrients. So basically feeding on empty calories. So this got us into thinking that maybe it was time for us to, since I'm a food scientist and she's an agribusiness economist, that we could develop an easy to use, ready to mix breakfast cereal that would be very high in protein and very high in fiber. And so we came up with our Smart Bite dry mix, and it is in the form of a powder that you can readily rehydrate with some water, cold water or hot water, however you like it. Okay, so as you can see here in our food innovation lab on the panel on the left, we have one of our students who is formulating the product and toasting it, right? And on the picture on the right, we have the finished product, which is in the form of a dry mix. It has a shelf life of about 6 months. And this has been subjected to a whole panel of tests, microbiological tests, safety tests, shelf life tests, nutrition composition tests, and everything. And one of the really important attributes is the fact that it has 5 times higher protein content and 2 times higher fiber content than all the other breakfast products currently on our market. So that is really one of our USP, our unique selling proposition. So we wanted to know, in the event that we wanted to commercialize it, well, who are our competitors, right? And we did a market survey and we went through the breakfast aisles of several supermarkets, and lo and behold, we found that 99% of the breakfast products out there are all imported, right? Imported from countries like South Africa, Australia, New Zealand, Indonesia, amongst others. But we only found one breakfast product that was actually locally manufactured. So this is demarcated in red here. So flooded with imported products, but only one locally manufactured. The same thing in other supermarkets as well. So then we got to thinking that the only way we could actually commercialize our product is to actually talk to that company who had already their product there. And we did some research. We found that this product has been on the Mauritian market for over 10 years. So this was a produced and marketed by a company. Actually, it's a woman-owned small-medium enterprise called DCF Roots. So DCF Roots Company Limited. And as you can see here, it has the word roots in it. And the reason being is that this is a close-up picture of their breakfast cereal, and their unique selling proposition is that their product is 100% cassava, right? And as we know, cassava has many important benefits. First of all, cassava crop is a root crop which is very climate resilient. So unlike all the other crops that we know of, like potato and wheat, right? This is for more climate resilient, so it can withstand a lot of the climatic stress. Also, it has no gluten. So for people who have like celiac disease and who cannot digest gluten, this is a very attractive option for them. So then we thought to ourselves that the only way we could commercialize this is to see how we could best align our product, which is the Smart Bite dry mix here, with the portfolio of products already marketed by DCF Roots Company Limited. So our product, as I mentioned, it has a lot of protein and a lot of fiber, and this is really good for you because it makes the product have a higher, what we call a satiety index. So when the consumer eats it, he feels fuller for longer, right? And this is because it has a 1-to-1 ratio of pulses to cereals. And DCF products and DCF Roots Company Limited, their product is called Maniodix, and it is made of 100% cassava. So then when we talked to them, we realized that probably what we had to make is something that brings the best of both worlds. So maybe a hybrid formulation that will still have a lot of pulses, still keep its high protein, high fiber characteristic, but also incorporate cassava because this company is what it likes to produce. And so voila, after 6 months of research, we did a lot of trial formulations, and we came up with our product, which you can see here. I have a packet next to me, and it's in French because in Mauritius we have a lot of people who are francophone. So we have a petit déjeuner, breakfast, à base de manioc, which means containing cassava. And some of its important traits is that it is rich in protein, low in fat, no sugar added, 100% vegetarian, right? So yes, so basically a high protein cassava breakfast cereal. So when we came up with this product, we also presented it to the directors, the two co-directors of DCF Fruits Company Limited. And as you can see on the picture here, we're trying to get their blessing and their approval to see if they really like it, because if they do, they are going to be the one to produce it and to market it. And finally, they did like it after a few fine-tuning. And on the picture on the right, myself and the co-director here, were jointly discussing on the best artwork to put this product on the limelight. And so we took the advantage of the University of Mauritius Innovation Week, which is an event where the University of Mauritius showcases innovative research. So here, myself on the right, together with my colleague in the middle, as well as the lady who is the co-director of DCF, was standing by our booth where we're trying to showcase the new product along with her own series of Maniodix products. So as far as marketing is concerned, the University of Mauritius, we produce research outputs in the form of technology and inventions, but we don't really have the infrastructure or the time or the setup to do marketing. But thanks to the fact that this company already have a Facebook page, if you can see here, they are going to leverage on their Facebook page to do a lot of e-marketing and digital advertising. Nevertheless, the University of Mauritius, we're also advertising this product on our website to indicate that this product is going to be launched in January 2022, as well as on our digital billboard on campus. Sorry, the picture is a bit blurry. And as well as taking advantage of any fairs and promotional events that we can lay our hands on. So here we have a student who is working with DCF Fruits and to market it and also tell consumers more about this product and why they should buy it, and to also get more and more publicity and visibility in anticipation of the launching happening next year. We had our Honorable Prime Minister, Mr. Pravin Jugnauth, who visited our booth, and this has also helped to get a lot of publicity and visibility. We know we have a burning question. How about the intellectual property rights? What are the important IP considerations? Well, the University of Mauritius came up with an intellectual property rights policy in June 2021 this year. So that was really, really timely. So in this policy, it really caters for instances like these where we have researchers coming up with tangible outputs, and if they want to license it to a company, how do we go forward? But thank God, in this policy, we have a template called the Intellectual Property Assignment Agreement. And this is a contract that it has already been drafted and filled up by the University of Mauritius as well as DCF Fruits. And it is in its final stage of being approved by the Director of Legal Affairs at the University of Mauritius itself. Other important IPR considerations, well, the Smart Bite name, just so you know, it is actually owned by the University of Mauritius, while the Maniodix is owned by the DCF. So Smart Bite, because it is owned by the University of Mauritius, in the future, if we decide to develop more products which have the health attributes, healthful, easy to use, affordable, low in fat, tasty, and high in protein, we can always market it under this Smart Bite trade name. Moreover, other things to bear in mind is that as far as ownership rights are concerned, the University of Mauritius, since we created this hybrid formulation, we get to be the primary owner, and DCF Fruits is the secondary owner. However, nevertheless, we are giving both of them equal visibility on the packet, with both logos being seen side by side and given equal visibility. One last aspect, which is the financial side. I know it's a busy slide. What I wanted to bring your attention to is that the launching of the product will be done in 3 phases. So in January, we'll be launching out 300 packets. Okay, it's the market penetration phase, so it's a slower phase. And these products will be placed on supermarkets for the mass market appeal, right? We want to compete with well-known breakfast cereals like Weetabix and cornflakes, which are already widely consumed. But we also want to target the niche market. So we also want to get the niche market appeal by placing it in various health stores. So in the initial phase, both University of Mauritius and DCF will be chipping in the ratio of 60 to 40%, as you can see here in the orange rectangle. And any revenue that we get will also, the university will also take in commensurate with how much we have contributed to the production. And the same will go to the second phase of production. However, for the third and any subsequent production batches, it's only the DCF Roots Company Limited which will be chipping in. So all production costs will be borne solely by DCF Roots, and the University of Mauritius will only be reaping a royalty to the tune of 2% out of the sales proceeds. So with that, I end my talk, and I'll be happy to take any questions. Thank you.
All right, thank you very much, Dr. Huda. Well, I should thank you for another thing. You are very active in giving inquiries to the previous speakers. Thank you very much. Okay, now we have 20 minutes of question and time, question and answer. If there's any of the participants who's willing, who's curious about one thing, you know, be it the presentation of Dr. Huda or the previous presenter, please raise your hand. Okay. Well, yeah. If you like, Dr. Huda, you can turn off your okay. All right. So I don't think we have any questions at this moment. But Dr. Huda, you asked about to Dr. Meenakshi a lot of questions. So how do you reflect the condition of perhaps what's been represented by Ms. Meenakshi over the condition of India? How do you project that with the condition in NAM regions, generally speaking? What I'm asking is perhaps it will be useful for the organizing committee to think about the follow-ups, maybe what kind of the activities that they should create, you know, to make sure the momentum is running. Thank you.
Yes, in fact, I was very impressed with, I believe it was Dr. Meenakshi's presentation, who mentioned that they have an IP cell in their center. And if Dr. Meenakshi is able to elaborate a little bit on the IP cell and how it manages to be so efficient at being able to process over 1,600 patents.
Okay, Dr. Meenakshi, Ms. Meenakshi,
Yeah. Thank you so much for asking this wonderful question. So how do we manage to file such? See, these 1,600 patents have been filed over the period of time. The first patent we filed in 2008, and today we are in 2021. This is point number one, right? The second point is we have a very dedicated and a strong IPR team with ourselves. So there are almost around 10 to 15 patent agents in this IPR cell. So those who are working very dedicatedly on working related to various issues of IPR filing, landscaping, drafting and all. So this is how we are managing.
And Dr. Amir, can I ask a second question?
Please, sir. Yeah, please, sir.
In fact, this question goes either to Dr. Meenakshi or Dr. Subendu. Once a technology has been transferred, how does the inventor protect himself in case the technology is wrongly used or abused? How does the inventor protect himself from any liability?
May I try to answer this question? Yeah.
Yeah, please,
See,
sir. Please, sir. Yeah.
see, the licensing agreement is between the two organizations, not the individual and the organization, right? So protecting inventor is not a question at all. So this is the agreement between the two organizations, that is the licensor and the licensee. So inventor is just the one who has developed the technology, otherwise the ownership lies with the institution. So it is the institution, that is one organization, which is taking measures and steps while signing the agreement with another party for against the abuse or the misutilization of the technology. I hope I have answered your question.
Right.
So there is no liability on the inventor actually.
All right. Dr. Subendu actually responded through the chat line. Yeah. Right. Would you like to add that?
Yeah,
yes,
just to supplement. Normally, as Dr. Meenakshi said very clearly, that inventor is not liable. But there is, even for the institute, it is taken care of by putting proper clauses in the agreement, in the licensing agreement. Even in our case, mostly it is non-exclusive, so others, there will be many users, many beneficiaries. Apart from that, where the technology is being implemented, there will be a clause saying that our institute people can enter there. I mean, they will be permitted to enter there and to see what is being done. So, I mean, wrong practicing may be avoided, and abusing by in case of what happens in case of exclusivity, that is mostly avoided by this non-exclusivity. Have I answered your question correctly?
Yeah, excellent. Yeah, thank you.
Thank you. Yeah, I believe so, Dr. Spandi. Yeah. Now we have Dr. Sophia Alvi. Would you like to ask something?
Assalamu alaikum, and thank you so much for giving me the opportunity. Okay, my question is about the importance of marketing surveys. I mean, you people have any specific teams which are doing the market surveys before you develop any technology or product, or it's the scientists who are actually developing the product and then going to market or going for any surveys? Anybody?
Okay. To whom you specifically address the question?
I can. I want Ms. Huda to answer.
All right. Dr. Huda, would you?
Yes, in fact, at the university, we don't have, we have something called a university industry linkage office. And technically, they should have been the one to do the market surveys. But because it's still at its inception stage, the onus really relies on the researchers themselves to go out there while they're conceptualizing the research to see who will be their competitors. So I think in our case, we did it ourselves. It took about 3 months to do that, but it was worth doing it, yeah.
All right, thank you very much for your response, Dr. Huda. Now we have Ms. Fatima Rubaiza. I believe you are from Malaysia. Please mention first to whom your question is being addressed and what's your question. Thank you.
All right, thank you. I would like to ask this question to Dr. Huda also, as because she is already in the midst of actually selling all this the technologies to the market. So just I wanted to know what is actually the policy of the university related to the licensing fee, and also the percentage of profit that later going to be gained from the technology transfer of the technology developed by you to the company? Is such policy, because that they're already in the midst of coming up with the IP policy, is there also mentioning something about the licensing?
Yes, thank you, Ms. Rubeza. Yes, as I mentioned, the University of Mauritius, we have come up with a IPO policy because not just our lab, but other labs have also been producing some very interesting tangible research outputs, and they are currently conversing with the industry to adopt it. So in that policy, it doesn't state anything about how much the royalty fee should be, although the director of legal affairs has stated that it should be between 5 to 10%. Like he has recommended that the royalty be between 5 to 10%. However, right now, because it is a breakfast cereal and it is a low-cost product, we are not able to get to that 5 to 10% royalty share at the moment.
Sorry, just on top of that, 5 to 5% on the gross profit or the net profit?
No, actually, it's on the sales. Yes, it's not on profit, because the director of legal affairs has said that the university should always be able to verify how many packets have been sold by the company, because it's on the number of units sold that we will earn our royalty, not on the profit. Because sometimes the profit, people can tamper with the values, but not with the sales, because you always have sales records.
So, Ms. Fatima, do you think Dr. Huda has answered your questions?
Yes, yes. Thank you very much.
Excellent. Now, thank you very much, especially to Dr. Huda, and which gets, give me the idea that perhaps NAM in the future should intensify meeting among actors in universities who's doing technology commercialization, in order to exchange ideas, perhaps business pitching someday. We are similar in our condition, and perhaps business interests that should be generated in the future. I mean, should be elevated in the future. Now, we remember that the presentation from Dr. Pir Muhammad went interrupted, but are you still here, Dr. Pir Muhammad? Well, unfortunately, he has left. Now, okay, so there is one question from Karuna to Professor Nyoman. Ibu Nyoman, are you still there? Okay,
yes,
so
yes.
Yeah, there is one question in the chat line. Can you please give more details about what is meant by sustainable education? Excellent question. Yeah.
Yeah. Sustainable education, it's mean like a lifelong learning. So just like a student is not only have a learning experience in our campus, but also they can also study with the community, like community engagement. So many issue or problem on their that kind of the community. So the student can also study with them, but also the academia. So we can do our community services or development with the community, and also with the stakeholder, with the government. So it's mean that we study day by day. Yes, so we cannot stop our learning experience with the society, with other partner from overseas or any other else. With the industry also, we can get like their problem, or we would like to also improve our product with the industry. Learning from the COVID-19 pandemic. So we also have experience like to do our vaccine product. So we have the learning experience regarding to the laboratory skill before the industrial, we have to move to the pilot, something like that. This is really, we have the sustainable also education with the industry, how to upscaling from the laboratory before the mass production. It's not also so easy, but then we can solve this problem. It's mean that we should study day by day. So this means lifelong learning, yes, for the sustainable education. That is the answer, Dr. Nurul, sorry.
All right. Okay. So how do you strike a balance between the, profit orientation, the nature of technology commercialization, and the noble idea? I'm putting quote unquote noble idea of the university that they should serve the public regardless classes or any creeds.
Yeah, we are in our university. We have also practitioner.
All right.
So like class teaching and learning is not only for the academia, but we are also invited practitioners. We also invited our alumni to join our teaching and learning. So then at that time, of course, the practitioner also can come from the industry. So then in Indonesia, now we have also the system of in the Merdeka Belajar Kampus Merdeka, yes, independence,
freedom,
freedom, freedom campus
in learning,
and learning, yes. So in this kind of the system also support our university to do more involving or engage with our society, alumni, practitioner, and industry.
So using the commercialization platform in order to attract the university coming to in order to attract the industry coming to university, and then recirculate the knowledge, redistribute it for the wider audience.
Yeah. And we also invited, we have marketing. So the same with like Dr. Meenakshi, yes, and also Subendu, that we have also marketing holding company in our campus. So this is the important thing to link our research result or product with the industry. So this marketing office will then socialize or branding the potential results, like we're doing like the vaccine, and then we look for the biopharmaceutical industry to join, and then we started with this kind of innovation. Yeah.
All right.
Something like that.
Yeah. Okay. All right. It was an interesting information coming from you and the other speakers, but unfortunately now we are already, heading to way than the mark that at the time mark that the organizing committee has given. Now, we thank you very much on behalf of the organizing committee. We thank you, speakers, Dr. Nyoman, Ms. Meenakshi, Dr. Pir Muhammad, Mr. Danis Eka Prasetya Wijaksana, Dr. Subendu, Dr. Huda, and all the participants today. Now, we have to cease the event and continue it tomorrow at the respective, time. Yeah. Okay. Thank you very much to all speakers from Fatima.
Thank you.
Okay, thank you very much. So you may leave the room today. Yeah, and see you tomorrow.
Yeah, see you tomorrow. Nice to see you all. Thank you, Dr. Manurul.
Thank you, everybody.
Thank you, everybody.
Bye-bye.
Bye.
Thank you.
Terima kasih, Pak Danis. Thank you. Thank you for.
Thank you. Terima kasih, Pak.
Thank you.
Thank you.
Thank you. Thank you.